In today's digital age, computer networking is the linchpin that keeps our world spinning. It's the invisible web that connects us all, fostering communication, data exchange, and collaboration across vast distances. Imagine a day without online shopping, no social media updates or video calls with loved ones. Picture a world where remote work is impossible and telemedicine is a concept of science fiction. All these activities that we take for granted are facilitated by computer networking. Consider the countless devices we interact with daily, from our personal computers and smartphones to servers in data centers worldwide. Each of these devices relies on networking to exchange information, whether it's a simple text message, a large file transfer, or a complex computational request. Without computer networking, our daily lives as we know it would come to a standstill. It's this intricate web of connections that keeps our world running smoothly, making computer networking an indispensable part of our modern existence. At the core of computer networking, we have network topologies, the architectural blueprints of our digital world. Network topologies are essentially the physical or logical layout of a network, dictating how different nodes or devices are linked to each other. They serve as the backbone of data flow, shaping the way information travels across networks. The design of these topologies is crucial because it directly impacts the performance, efficiency, and reliability of a network. Let's explore some common network topologies, starting with the bus topology. Picture a central cable or bus with all devices connected along its length. It's simple and cost-effective, but can face congestion issues when multiple devices try to communicate simultaneously. Next, we have the star topology. Here, all devices connect to a central node. This central node acts as a conduit to transmit messages. This topology is reliable. If one connection fails, others remain unaffected. However, if the central node fails, the whole network goes down. The ring topology, as the name suggests, forms a closed loop. Each device connects to two other devices, forming a circular pathway for signals. This topology is easy to install and manage, but a single break in the ring can disrupt the entire network. The mesh topology connects every device to every other device. It offers high redundancy and reliability, but can be expensive and complex to manage due to numerous connections. Finally, we have the hybrid topology, a combination of two or more topologies. It brings together the strengths of various topologies while mitigating their weaknesses. But the complexity of design and higher costs are its major drawbacks. Each topology has its pros and cons, and the choice depends on specific network requirements. A bus topology might work for a small office, while a mesh topology could be ideal for a data-intensive environment like a university. The choice of network topology significantly influences a network's performance, cost, and reliability. So understanding these topologies is a key step in mastering the art of computer networking. Just like a city needs roads, signals, and bridges for smooth traffic flow, a network requires various devices for efficient data transfer. Let's start with switches and routers, the traffic managers of a network. A switch is like a traffic signal at an intersection, directing data packets along the right paths within a local network, ensuring they reach the right device. On the other hand, a router is more like a GPS system. It finds the most efficient route for data to travel between different networks, whether it's from your home computer to a website server halfway around the world, or from one office to another in a company's wide area network. Next, we have hubs and bridges. Imagine a hub as a roundabout where all traffic comes and goes freely. It's a device that connects multiple computers within a network, blindly broadcasting data to all connected devices. A bridge, however, is a bit smarter. It's like a bridge over a river, connecting two separate roadways. In networking, it connects two separate network segments, filtering traffic and reducing unnecessary data transmission. Moving on, let's talk about modems and access points. A modem is the translator in our city of data. It converts the digital signals your devices understand into analog signals that can travel over telephone or cable lines and vice versa. An access point, on the other hand, is like a public Wi-Fi hotspot. It allows devices to connect to the network wirelessly, acting as a conduit between the device and the network. Last but not least, Firewalls and gateways play crucial roles in network security and routing. A firewall is like a vigilant security guard at the city gates, checking every data packet's credentials and blocking any suspicious or unauthorized data from entering or leaving the network. Meanwhile, a gateway is the city's main entrance and exit point. In a network, it's the point where two different networks meet and interact. In essence, each of these devices has a unique role in the network. Like the infrastructure of a bustling city, they work together to ensure data moves smoothly and securely from one point to another. They help us stay connected, whether we're sending an important email, streaming our favorite show, or keeping our devices safe from cyber threats. Remember, understanding these devices and their functions is key to mastering the art of computer networking. So, the next time you connect to the internet, take a moment to appreciate the complex symphony of networking devices that make it all possible. These devices, each with a unique role, work together to ensure seamless connectivity. Now that we've understood the theory, let's see how these topologies and devices function in the real world. Consider the bustling environment of a modern office. Here you'll often find a star topology at play. Individual computers or nodes connect to a central switch or hub, forming the shape of a star. This setup allows for easy addition or removal of devices without disrupting the network. It's also easier to troubleshoot, as a problem in one node doesn't affect the others. On the other hand, a mesh topology is commonly found in wireless networks, like those in large open spaces such as universities. Every node is interconnected, providing multiple pathways for data transmission. This redundancy makes the network robust and reliable, as data can still reach its destination even if one node fails. Now let's talk about devices in action. Take the case of an internet service provider or ISP. They use routers to direct internet traffic to your home or office. These routers, equipped with firewalls, also provide a first line of defense against cyber threats. Switches, on the other hand, are the unsung heroes in data centers. They direct data packets within the network, ensuring that information reaches the right destination efficiently. There's also the story of a small business that improved its network performance by replacing its hub with a switch. The hub, which broadcast data to all connected devices, was causing data collisions and slowing down the network. The switch, with its ability to send data directly to the intended device, eliminated this issue and significantly increased network speed. Lastly, consider the role of modems and access points in our daily lives. They enable our home networks, connecting our devices to the internet. Whether we're streaming a movie, attending a virtual meeting, or controlling smart home devices, these essential devices make it possible. As seen in these examples, the right combination of topology and devices can greatly enhance network performance. Maintaining a network is like keeping a car in top shape. It requires regular checkups and timely repairs. Network administration is akin to being a mechanic for your network. It involves keeping an eye on the overall health of your network, ensuring data flows smoothly and securely. Every device, every connection, and every piece of data that traverses the network is under the watchful eye of the network administrator. But what does this entail? It means monitoring the network for any unusual activities, such as sudden traffic spikes, which could indicate a potential problem. It's also about managing the network's resources, ensuring that every device gets its fair share of bandwidth and no single device hogs the network. And then there's troubleshooting, the art of diagnosing and fixing network issues. This could range from simple fixes, like restarting a router that's acting up, to more complex problems, such as identifying and rectifying a network bottleneck. In some cases, troubleshooting might involve delving into the network's logs to identify patterns or anomalies that could point to the root cause of an issue. It's a bit like being a detective, sifting through the clues to solve the mystery of the misbehaving network. And let's not forget the importance of proactive measures. Regularly updating software, changing default passwords, and setting up firewalls can prevent many network issues before they even occur. Effective network management and troubleshooting ensure the network stays up and running, minimizing downtime. As we wrap up, let's reflect on the journey we've taken through the world of computer networking. We've navigated the intricate map of network topologies, delved into the toolbox of networking devices, and explored real-world applications. We've also picked up some handy troubleshooting tips along the way. The power of understanding networking lies in this knowledge. Whether you're a tech enthusiast or a networking professional, a solid grasp of these concepts is a powerful tool in the digital age.